Hello everyone, I'm Harish and today we are going to talk about my project which is a multi-threaded proxy server built in Go language with in-memory caching support. So first let's try to run it live and then we are going to talk about what is the workflow that what are the steps we took to build it. So let's first head over to our Postman. So in the Postman settings, I set up the proxy to my port local 9000. So every request will went through the my multi-threaded proxy server. So first run it. So the proxy server is running on port 1000 and we are going to test it. So this is another server on running on 1316. So okay, first I have to run it. So this is another server which is running on port 1316 and I am going to send request. So it will went through I right. Okay, something is wrong with my target server. Okay, let's try again. Okay, request is forwarding and successfully, and let's try to send another post request to sign up. Okay, that's okay. So something is wrong with my target server. Wait. Yeah, I know. I have to. So my target server is using an container database. So I have to run that. Wait a second. That will do it. So wait. So now our target server is running. Let's try and test it again. Okay. So user is signed up. So every request is now finally is sending correctly. Let's send up. Now, yeah. So what it's saying that sending response from LRU Cache. So I when I repeatedly send this request, it is going to check this request, and if it is stored in the in-memory cache, it will take response from that rather than sending to the target server. So it is helpful. It is helpful to minimize the time. And yeah, there is another issue which is we are going to face. Let's say if the target server is updated or what. So we are not establish a caching termination policy. So when to keep the cache for a certain period of time or not. So that is it. And now we are going to talk about the code. So how is the workflow? So how it is multi-threaded. We are handling each request in a separate thread. So we can run go routines using the go prefix in front of the function. And now there is a function which is going to handle the all the requests. So first of all, we are working on the TCP level. So first, what is this? So this is a semaphore. Let we do not want to someone DOS attack our proxy server. So what we are going to do is we are going to mitigate this DOS attack scenario with semaphore. So I'm going to what I done is I build a buffered channel. So it is so what are channels? So channels are used when you want to talk between two or more than two go routines. So there has to be a receiver and there has to be a sender, and then it will work. Otherwise, it will be get blocked. Those are unbuffered channels. And what are buffered channel? Buffered channel have predefined capacity. So let's say we define that capacity to 10. So sender can send the data of 10 times, and even if the receiver is not there, it will still work. And if it crosses over 10, then it will get blocked. So we defined our buffer channel with 20 request max. And when this handle function start executing, it will pass a empty struct into the channel. So the capacity is now 1, and now what it's saying, it is I'm executing a defer function and passing the sema, and sorry, receiving the object from the sema. So this is the sender, and and this is the receiver. I'm receiving at the end. So let's say if 20 requests come, 20, so the handle struct 20 struct will be passed into the channel, and after channel done executing, then it will receive it. So the max client goes down. So we have another so that another request can come. So at one time 20 request can come at most. We can do it around 100 also, we can do it. And then it will send a it will read the connection, and it will prepare, sorry, it will read the request and check that the request is in the our in memory cache. So we are going to talk about our least used cache, LRU. What is the full form of the LRU? I forgot. Least, what is called? Least recently used. Yeah, we are going to talk about how I implement that. And first it is going to check if the request is stored in the cache or not. Then if not, then it is going to uh, forward the request to the target server. So how we are doing that? We are creating a connection and dialing. I told you that we are opening a socket connection on TCP level, and we are preparing the request manually, headers and the status code and the body, and we prepare the request and send it to the uh, target URL, target host, and then we are going to read the response and return back the response. And if we get the response correct, then we are going to write to the client which who who send the request. Yeah, and finally save it in the LRU cache. So how we implement the LRU cache? Using the linked list and the hash map. So the complexity is big of one only. We are using the linked list to insert and setting the high priority. Let's say if let me show you. So let's say if our LRU cache have an limit of 2, so it can take up to 2 requests, store 2 requests, and the first one is this request, and the second one is this request. So the last used request is this, so it is of high priority, which is the which we set by using head uh, in the linked list, and this will get the low priority because it will in the last. And let's say if another third request come, then the list you list recently sorry, the list used request will be evacuated from the cache. So currently I think capacity of the cache is 2. We can increase it to the 10 and test it again. You can benchmark this tool also, or proxy server, using the Apache benchmark. Let's see. Okay, something is failing, but okay, yes, it is sending the request from the LRU cache. We are not even forwarding the request to the target only one time. Okay, that's it for today.